Alright, so we have completed 5 of the 7 sections, and now we will do the 6th section, linear inequalities in one variable. Okay, so far we did equations, but now we will do linear inequalities with the variable on one side. So let's get started right away with this basic example. Solve 2x minus 3 less than 9 and then graph the solution on this number line. So how do we do this? Well, it's actually very similar to solving linear equations. We have to isolate the variable and then find the set of values that it can take. So 2x minus 3 is less than 9. So let's add 3 on both sides. So that will give us 2x less than 9 plus 3 or 12. And remember that if you add the same thing on both sides of an inequality, that inequality will still hold. So 2x is less than 12, and now you can divide both sides by 2, and once again the inequality would still hold. So let's divide both sides by 2. So we would get 2x over 2, which is x, less than 12 over 2, which is 6. Okay, so this is the solution to this inequality. X should be less than 6. So how do we graph this on this number line now? So x should be less than 6, which means that x can take any value less than 6 on the number line. So 6 is over here and x cannot be equal to 6. So I will draw a hole on 6 to represent that x cannot be exactly equal to 6, but x can and will take every value less than 6. So then what I'll do is simply draw a continuous line or ray to the left of 6 like this. So which essentially represents that all points on the number line to the left of 6 essentially form the solution set for this inequality. So this is how you would graph the solution set of an inequality. Now let's do this next example. Solve negative x plus 5 greater than equal to 4, and once again graph the solution on the number line. Okay, so let's first get rid of this 5 and subtract 5 on both sides, and the inequality would still hold. So negative x greater than equal to, I'll get 4 minus 5, which is negative 1. Okay, but I need x. I need the solution in terms of x, but I have a negative x on the left side. So what do I do now? Well, I can simply multiply by negative 1 on both sides. So I get x on the left side, and negative 1 times negative 1 is 1 on the right side. But very importantly, and this is a super important point, when you multiply across an inequality by something negative, or you divide by something negative, the sign of the inequality or the direction of the inequality changes, it reverses. So greater than equal to would become less than equal to, and this would be the solution for this inequality, x less than equal to 1. So let's graph it now on the number line. So less than equal to 1 is over here. So and we also note that x can also be equal to 1. So let's plot this hole as a filled hole, which simply represents the fact that x can also be equal to 1, but can then also take all values less than 1. So let's draw a ray to the left of this point, continuous ray, which means that all points to the left of 1 also form the solution set of that inequality. Now here's a nice SAT sampler on linear inequalities. Negative of 8 minus 10c over 8 is greater than 3c minus 2. Which of the following describes all possible values of c? So the inequality might look complicated because you have the variable on both sides and you have to isolate it to one side. But if you do it step by step, it's actually fairly easy. So let's look at the left side. We have an 8 in the denominator and we have a negative sign. So let's multiply by negative 8 on both sides, because that will help me get rid of both this 8 and this negative sign. So we multiply by 8 on both sides. So on the left side I should get 8 minus 10c. On the right side I should get negative 8 times 3c minus 2. But once again, and I'm reiterating this very strongly, you have this greater than sign here, but because you're multiplying by something negative, you're multiplying by negative 8 on both sides, the direction of this inequality would reverse and it will become less than. So that's the key step here. 8 minus 10c is less than negative 8 times 3c minus 2. Let's simplify this now. So 8 minus 10c is less than, now let's open this parentheses, negative 8 times 3c is negative 24c, and then we have negative 8 times negative 2 is plus positive 16. Okay, now we have to isolate c, so let's collect the combine the terms involving c. So I have negative 24c over here, and then I have a constant 8 over here. So let's add 24c on both sides. So on the left, the 24c and negative 10c will become 14c. So 14c plus 8 less than 16. And now let's get rid of this 8 by subtracting 8 on both sides. So I get 14c less than 16 minus 8 is 8. Okay, and now I can divide both sides by 14, and that will give me c less than 8 over 14, and 8 over 14 can be reduced to 4 over 7. So I can write this as c less than 4 over 7, which is option C. So option C is the correct answer. Now this next SAT sampler says if negative 5y minus 7 is less than equal to 8, what is the least possible value of 15y plus 7? So many students might do this. They might take this inequality and solve this completely, find the possible solution set for y, and then use that to figure out what would be the least possible value of this expression. But we'll be a little bit smarter than that. We will observe that in this inequality we have negative 5y, and in this expression that we need we have 15y, and I can go from negative 5y to 15y by multiplying with negative 3. So all I'll do is first multiply both sides of this inequality by negative 3. So let's do that. On the left side I will get or actually let's just write it properly first. Negative 3 times negative 5y minus 7 on the left side, and then on the right side I'll get negative 3 times 8, which is negative 24. But once again, and again, because this is a very common mistake, we had a less than equal to sign here. This sign will now, this inequality direction will reverse and it will become greater than. So okay, so now let's open this parentheses, distribute minus negative 3 over these terms. So I get negative 3 times negative 5y is 15y, negative 3 times negative 7 is 21, and then I have negative 24 on the right side. And now I observe that I have 15y plus 21 on the left side, and what I need is the least possible value of 15y plus 7. So how can I convert this 21 into a 7? Well, if I subtract 14 on both sides, this 21 will become a 7. So I subtract 14 on both sides, so I'll get 15y plus 21 minus 14 is 7, greater than equal to negative 24 minus 14, which will be negative 38. Okay, so the minimum possible value therefore of this expression 15y plus 7 should be negative 38, because this expression is always greater than or equal to negative 38. So negative 38 will be the least possible value of this expression. So option C is the correct answer. Now the next theme in this section is compound linear inequalities, and that simply means that we have more than one inequality to solve together. So in this SAT sampler, for example, we have one inequality that says 5x minus 7 greater than equal to negative 5 and 3 minus 2x greater than negative 2. And which of the following values of x is a solution? And when we say a solution, we mean a solution to both this and this together. So a solution should satisfy both this inequality and this inequality. So let's find the solution sets of both these inequalities first, and then see which one of these values lies in both of them. So 5x minus 7 greater than equal to negative 5. So let's add 7 on both sides. So we get 5x greater than equal to negative 2, or actually positive 2, because you have 7 plus negative 5 is positive 2, and this gives you x greater than equal to, if you divide both sides by 5, x greater than equal to 2 over 5. Okay, so that's one possible solution set. And then what about the second inequality. So 3 minus 2x greater than negative 2. So let's add 2x on both sides. So 3 greater than negative 2 plus 2x. Now let's add 2 on both sides. So we get 5 greater than 2x, which I can write as 2x less than 5, or x less than, if I divide both sides by 2, I get x less than 5 over 2. Okay, so one solution set is x greater than or equal to 2 over 5. Another solution set is x less than 5 over 2. So now we need to find that value of x from these four options which lies in both this solution set, x greater than or equal to 2 over 5, and this solution set, x less than 5 over 2. So we can simply go through each of the options. So let's see 4. So 4 is, yes, it's greater than or equal to 2 over 5, but it's not less than 5 over 2. So 4 is ruled out. What about 5 over 2 itself? Here we have x is less than 5 over 2, not equal to. So this option would also be ruled out. What about negative 1? So we need x to be greater than or equal to 2 over 5. So negative 1 is also ruled out. What about 5 over 3? 5 over 3, yes, it is less than 5 over 2 and it is greater than or equal to 2 over 5. Or just by elimination, you could say that this is the only correct option. So 5 over 3 is the answer to this for this problem. Now the last theme in this section is modeling real world situations using linear inequalities in one variable, and here is a nice SAT sampler on this theme. To rent a kayak, there's a $25 deposit you need to pay upfront no matter how long you use it. On top of that, there's a $10 rental fee for every hour you spend on the water. Okay, so let's say you plan to rent the kayak for T hours and want to keep your total rental cost under $75. So you don't want to exceed $75. Which inequality represents this situation? So your total rental cost will be a sum of the deposit, which is $25, which you have to pay no matter how much time you spend on the water, and then for every hour there's a $10 rental fee. So if you spend T hours on the water, the rental fee will be 10T, and therefore the total rental cost will be a sum of 25 and 10T. So 25 plus 10T, and you want to keep this, you don't want this to exceed 75, so this should be less than or equal to 75. So that's it. This is the inequality that represents the given situation, and this is in option D, 25 plus 10T less than or equal to 75. So option D is the correct answer.